Cool. So I, like Adam, was particularly obsessed with VerbNet and trying to figure out whether or not there was any ways to use vector embeddings to be useful in VerbNet classification. I wanted to know whether or not we could use particularly dep2vec in order to see whether or not we can find useful relationships that can be used for the classification of the 11 class of verbs. And so I have a lot of background on this, or I have a chunk of background that we probably could go through, but given the amount of time, I'm going to skip to the last two most relevant ones. No, I'm going to skip right to dep2vec and why I think it's a useful thing to use in VerbNet, and then I'm going to go directly to the models and everything I tested. Because at the end of the day, because I started on this pretty early in the semester, I ran about 6 experiments. And I think going through what those are, how they're functioning, and some of the assumptions in those is the most important part of this presentation. So we're going to say goodbye to this. All right. Yeah. So dep2vec. What's the point here? So one of the things about dep2vec, as it was implemented by Levy and Goldberg in 2014, is it uses the same bag of word approach to creating word vectors. It just changes what the input features actually are. So rather than using every word in a sentence now, you break the sentence down into its dependencies. You then feed the network that you're training everything on, like the head functor, so like that first word that's like the mother of all the dependencies in it, and then all of its sort of daughters. And so you get, for a sentence like John gave Julie a sandwich, which sounds delicious, but you get gave John Julie sandwich because those are the nominal arguments that attach to the verb. But then you also get John as its own unique sort of instance, you get Julie as its own unique sort of instance, and then sandwich, because it has that modifier it gets that put into it too. And so rather than taking every word in the sentence then, you feed your encoder this information. And that gives you some pretty interesting results. So according to Levy-Goldberg, there's some utility from this sort of constrained context. For example, you get increased domain-related information in the vector encoding. So whereas if you're using bag of words with just like 5 things and you're talking about Batman, you're going to get things like Nightwing and Aquaman and Catwoman, all these superheroes, Superman, Superboy, et cetera, and so forth. With the dependencies, you get kind of similar. But it gets even cooler when you start moving from the domain of like a person to like domains of places and people. In the bag and words approach, you get things like Dumbledore, Hollows, Half-Blood, all these things that have to do with Hogwarts. But if you're using the dependency method that they're talking about, you end up getting a lot more information pertaining to the actual locations. You start getting things that deal with sort of places. Hogwarts is a place, Sunnydale is a place, et cetera, and so forth. So instead of you really getting an output that has to do with all the things that are related to the text in terms of what might occur alongside of it, you get these domain relationships. It's no longer Hogwarts in terms of Harry Potter, it's Hogwarts as a place. And so the intuition behind this is that due to it capturing this information and due to the fact that it's constrained to a domain, this means it's probably capturing some useful information about the semantic roles themselves, or at least it has information in there that can be used for it. Simultaneously, because of the way the bag of words approach works as well, it should be capturing some of the information about the linear order of these things and where they're occurring in that sentence. And that should be contained in that vector as well, which harkens back to Risinger et al. We know in English that linear order is a useful and critical tool for us making sense of what thematic roles are being used in that sentence. And so if we're using a vector that actually captures that information, perhaps we can use this to really do some more VerbNet classification without having to go through the whole process of really going through all the different classes of VerbNet. Spoiler alert, that assumption wasn't entirely right. And so I ran 6 experiments on this. I did some K-means clustering of the dep2vecs. I also did some logistic regression of these dep2vecs. And as my 6th experiment, as sort of a standalone, because I had this sort of neural net that I worked on for NAACL, I was like, what the heck? I'll run it through this and see what happens and see what the results look like. That was not part of the proposal, and the results from that seem really good, but there's a lot of caveats for it, so it's just fun to talk about regardless. Before going on, we should probably talk a little about what the data structure was that I used. And so in order to get the data that I was using, I took the Wall Street Journal 400K corpus as it was on the verbs.colorado.edu server. Thank you, Dr. Palmer. Thank you, everyone who puts those corpora on there. And so then I just ran a dependency parser over it. Spoiler alert, This is from the NAACP, the sentence from the NAACL paper also. I changed sort of like what the actual data structure looks like for this project because my data structure for that paper and this one are different. So you run the dependency parser, and what you end up getting is per each verb in the sentence, so we're going to focus on pushing here, you get an output like this via Stanford's dependency parser. You get pushing, which is the verb. There's a null instantiated subject in this particular instance, so it's just replaced by a 0. You get people as a direct object. There's no indirect objects, still a 0. And then the preposition and then the oblique nominal modifier into poverty. And so all of this gets packed into a list, which can then be used for any sort of analysis you want. I took this list, I then converted each word into a lemma, and each lemma was then converted into that dep2vec sort of representation from the Levy-Goldberg. And then that's where the real fun starts, because that's when I started getting to actually experiment on what was going on. In order to do this, I figured we needed to have a couple of predicate logic models. I like neo-Davidsonian predicate logic. I like it a lot, especially since it makes my job easier on this particular, in this particular domain. So here are two neo-Davidsonian sort of predicate logic models that I tested. I wanted to see which one worked best. So first, I have this 300-dimensional model, and it's pretty easy. Each argument's vector is added to one another using just vector addition. This creates a 300-dimensional vector of the representation of the sentence. Simple, flat, easy. As a visualization, it looks a little bit like this. Of course, there's 300 of these bad boys, but visually this is what it would be like. I just take vector 1, vector 2, vector 3, whatever, add them together, and then I use that new created 300-dimensional vector as my sort of input into the clustering algorithm. Secondarily, I did an 1800-dimensional model. Now in this model, what I did is each vector was retained as it is, just as a 300-dimensional vector. I just made a giant vector out of all of them. And so now you have this 1800-dimensional vector which you can use as inputs. And it looks a little bit more like this. Everything is separate, it's all there, it's just a really, really big vector. Not pictured on here, though it should have been here, is I did a third experiment, or a third model with this also. I took each individual vector, so all the vectors for subject and the labels for them, all the individual vectors for direct object and the labels for them, and I used K-means clustering on that also to see whether or not there were any useful relationships in each individual vector. That'll be important when I get to my results. And so in experiments 1 through 5, it was basically just using K-means clustering, or no, it was logistic regression for both of them. I mislabeled that. Excuse me. Oh, this might be an old model. Yeah, this is an old slide. Okay, whatever. So we're going to focus on this part right here, logistic regression. I basically just used the scikit-learn toolkit. The solver was a Newton NG or CG solver, and I used a multinomial sort of logistic regression. And then I fed it the two models, the 300-dimensional model and the 1800-dimensional model. For this one, I did not do each individual sort of like grouping of verb, subject, et cetera, and so forth. And then experiment 6, playing around with this deep neural network. All the results and discussion are after this. I figured it'd be good to go through the implementations and then we can focus on the results. And so in addition to the arguments used in experiments 1 through 5, I fed as inputs into this neural net a set of representations, of interactions that I think usefully represent parts of the construction itself. Now, so you get things like, this is the argument set representation from before, pushing, 0, people, etc. But then you're looking at verb and subject, the interaction of verb and subject, so pushing in the null instantiation, pushing in people, pushing in the indirect object, etc., and so forth. The intuition behind this is that it's not just the words themselves, or just saying that, hey, this is direct object, indirect object. The real crux of this sort of constructional approach is when you get something like, oh, this is too small. Poverty is going to be abbreviated, I apologize for that. Pushing into poverty. The information about a construction really has to do with this sort of template. And so what we're interested in is this relationship here. Knowing that these two are a unique instantiation of a particular semantic frame, knowing that these two only occur the set number of semantic frames, knowing that this is an n-mod relationship, which also occurs in that semantic frame, this information can be used to help classify what the actual verb semantics are. And so all of these, by using the actual input words, gets at this. It says that pushing into poverty or pushing and poverty are unique instantiations for a particular frame, but the relationship itself is also unique to that frame. So you feed in all the lexical items, you feed in these relationships, these unique instantiations per verb frame, and then you sort of see what you get out of that. And so all primary features were used, and then all of these were then used also. I converted each one of them into a numeric value, and then from the numeric value, converted that to a 13-dimensional, it wasn't 13-dimensional, it was 12-dimensional. A 12-dimensional like embedding layer, which was then used as the inputs for TensorFlow. This is just sort of a visualization of what the model looks like. Yeah, I recognize that between this layer, which has a dense layer of 100 hidden units, that's not really 100 connections. I got really tired of drawing these guys. But my network architecture is basically like this. I use just a basic deep neural network, a deep feed-forward neural network. There's some way of combining those words that makes more sense than what I'm saying. Activation function was just a ReLU function. It had two hidden layers, one with 100 units, another with 50 units. I used a dropout rate of 0.4 throughout the training so that it wouldn't like overfit. And then I ran it for 500 APOCs, which was a pain in the butt letting my computer sit there because I did it stupidly on my Mac. You don't put your Mac on your lap after about 200 APOCs. I got interesting results. So first off, that 300-dimensional vector, yeah, that didn't work at all in terms of accuracy. When I used it I trained everything in training and testing data. When I tried to go ahead and use it to classify the test data, it got none of them right. Absolutely none. For that 1800-dimensional vector, it got a little bit more interesting, but not enough to really be worthwhile. It got 0.16% for K-means clustering. Where it got cool and where it got weird was that when we were looking at the clustering of the individual arguments, the nominal modifier, so all those oblique nominal arguments, and the subject, those two were useful for clustering. So the nominal modifier got the highest accuracy out of that set, and it got to 71.4%. And I have some theories on that. I'll talk about that afterwards in a second. Logistic regression obviously worked better with the two models than, say, like K-means clustering did, by a pretty significant amount. And then the neural net, which again, there's caveats for it. It got an insanely high accuracy, but I think that might have to do with some artifacts of the training data. I don't think that that's actually, I would want to test this method on real VerbNet data, like the actual training and test data for VerbNet before I claimed anything with this network.
Remind me what your training and testing data was?
I forgot to put that on there. So the training and testing data I went to Kevin Stowe. I wanted to see if I could augment the data using some of the VerbNet, FrameNet sort of semantic linkages that Kevin Stowe has built. So I went to his API for Semlink. I took all those VerbNet, FrameNet extensions, and then I went from those, I pulled the verbs out of FrameNet, and then I went to the Wall Street Journal corpus and searched for those verbs and created like training data out of those.
For how many classes?
That gave me 51 classes. So it's not nearly enough to make a lot.
So you took the classes that had the most overlap between VerbNet and FrameNet?
Mm-hmm.
Yeah. And then you took just the verbs from FrameNet?
The original thought was to go ahead and take the verbs and the nouns, but I screwed up on my code and I didn't realize it until about
Well, that's
yesterday.
okay, because this has got all these syntactic features which are going to not work the same way for nouns that they work for verbs. So, okay, so then you took the verbs from FrameNet.
Mm-hmm. And then I took the verbs from FrameNet. Once I went ahead and got all the data, or I got all like the sort of data from the Wall Street Journal corpus using those verbs collected from FrameNet, there was a lot of overlap between them because a lot of verb classes have the exact same sort of verbs in them.
Yeah.
And so I reduced it by saying any sort of like overlap between the classes. So like say, I'm trying to think of an exact example, but let's say like class 1 has pushing into poverty, and class 1 has the verb pushing, class 2 has the verb pushing also, but for whatever reason they're just different in terms of nominal arguments. Because I only collected the verbs and I didn't use the nouns like I should have in the first place, It basically said for both of those classes it had pushing into poverty, pushing into poverty. So what I did is after I had all this data, which was over like 20,000 sentences, I went and said any overlapping sentence, any sentence that was the same between the two of them, take that out of the training and data set entirely, which reduced it down to about 3,000 sentences.
Sorry, any sentence that was the same between the two of what?
So, never clear. Let's say like
Between VerbNet and FrameNet, or between?
between the different frame nets, the different frame net frames. So what it did is because it collected the verbs, let's say like frame net frame had pushing, or one frame had pushing, another frame had pushing also. Because of that, they would both collect pushing into poverty. And so if pushing into poverty was collected in both of those, I just said that that sentence should be taken out.
Because it was ambiguous.
Right.
Okay. Okay.
And so that still left 3,000 sentences. And when I checked the overlap between like how many verbs were between each setting also, the average overlap was still at like 98% in terms of like the verbs that were there, not the sentences.
Between VerbNet and FrameNet? The overlap
Between the different
what?
frame net instantiations. So like for instantiation 1, even after taking out like these, if it had the same sentence in like frame number 1 and number 2, taking out the sentences that were the same still left an overlap of verbs at 98%. So it's basically saying that between these two frames, it still had pushing, it just didn't have the same sentence. It took out all the ambiguous sentences, but left behind similar verbs.
So you still had multiple instances that had been mapped to pushing, but they had been mapped to two different frames that included
Right.
pushing.
But it now, because I also focused on what arguments were associated with it, it now had only arguments that were associated with that frame. It didn't have any overlap between the two of them.
Okay.
The arguments stopped overlapping. The verbs were still there.
But wait, does that mean that you only classified like a single sense per verb?
No, because there were still verbs in each class that overlapped between them. It's just the number of those overlaps were a lot less because it didn't have the same sentence throughout.
Oh, exactly.
I got rid of the
same
ambiguous
sentence.
sentences. The verbs and their different sentences were still represented.
Oh, okay. And so you sampled your training and test data from that set of 3,000 examples?
Mhm.
And
3,784.
oh, nice. Like 80-20 split kind of thing?
Yep.
And you, so those samples were from Wall Street Journal?
Yep.
So how, were those hand annotated by VerbNet annotators? Or classified?
If they were, I didn't use the annotations.
So how did you know the gold label?
Well, that's the caveat. I think that even within like getting some of the training and test data, I need to test this on like actual VerbNet data, these methods. The way that I knew the label was mostly from Kevin Stowe's annotations of what like the label for the VerbNet, like FrameNet frame mapping should be. So it collected these things, gave it a VerbNet frame. It collected these verbs given the FrameNet, like the amount of the verbs that were in FrameNet.
FrameNet is annotated for these.
Right.
Oh, okay, now I see.
So you used the manual annotations for evaluating the tests on the test set?
I used the annotations that were provided from Kevin Stowe's sort of computer, yes.
Or
from his-
For training and for testing?
Yes.
Okay, okay.
Yeah, that makes sense. For a second, I thought you were automatically labeling and predicting those labels. But I see what you're saying. So this is like a proof of concept of these methods applied to a cleaned example.
Right.
Yeah, cool.
Again, the results from here are interesting, but I think that to really claim anything, it would require me to get like the actual gold training and test data from VerbNet and really play around with that.
Yeah, I mean, you'd have to use the same tests, the same data sets that were used in the published papers and then do a comparison to those results. But this is interesting. So it was sort of doing sense tagging. It was a neural net doing sense tagging based on 80% training data and then evaluating on 20% test data. And the data was not, it wasn't monosamous data, but it was polysemous data where there was a clear distinction between the senses.
I think
Yeah,
that-
so it would be interesting to see how it worked with where the Polismus data is fuzzier.
I would love to get my hands on the actual VerbNet training and test data and give it an actual run.
Oh, we should be able to do that.
I figure, I just haven't had the time to yet.
Yeah, yeah. I mean, Susan Brown should have it.
Okay.
Should be on verbs. shouldn't it?
Yeah, she should know where it is, I think.
Okay, I'll ask her then. I always like hanging out with Dr. Brown anyway, so. Anyhow, so last little things on this one. I think that the end mod varies according between frames because of the semantic role differences in particular. For example, in sentences like John broke the news to Sarah, when it's a transfer event, you assume that that nominal modifier ought to be a person. But when you're doing like a description of how news was sort of presented, like the idea of breaking news as a bad sort of thing, the nominal modifier changes to like a location or medium of transmission. And so I think that's why the nominal modifier ended up being accurate. It's because in the nominal modifier, like in that oblique and nominal argument, that those tend to be like highly specific to the VerbNet frame.
But your nouns aren't annotated with person and location, are they? How did that happen?
That came from the dep2vec. I think dep2vec, because it had like the capacity to say that like the domains are very different, it was able to say, no man, person is one thing, location's another.
Yeah, okay, fair enough.
So dep2vec was useful for that, but it's just not useful for like everything. So focusing on the nominal modifier and focusing on the subject in particular is useful. The subject again was at like 53% accuracy. So that's cool. And then I would just explain why I think the usage-based construction grammatical features are useful. And then works cited, and that's my project.
Okay, thank you. Well, lots to think about. It's hard to do, isn't it? Well done, thank you. Thank you, all three of you. So Thursday will be Chelsea, Annabeth, and Shauna too. And what order would you like to go in? Chelsea, do you want to go first or last?
I'll go first.
Because the other two should go together,
Okay.
one way or the other, so, huh?
I'll go first.
First, okay, so then Annabeth, why don't you go last?
Last. Okay.
Okay.